Hi, students. Happy day before St. Patrick's Day. We'll start with a do now where we'll talk about helpful and unhelpful thoughts in response to a particular scenario. Our objective today will be to work on applications of exponential growth. We're only doing growth today. We'll do exponential decay tomorrow. Our essential question asks, how do I solve applications that represent exponential growth? So remember, those graphs look like this with that rapidly increasing curve. Our assignment will be to complete the do now, the exponential growth applications. We have an exit ticket. And then if you are in person, I will walk around and see your work. Please make sure you have your notes with you. If you are a distance learner, you upload your photos to Teams. Tonight we'll do homework 8, but be careful. We only want to do problems 1, 4, 6, and 8. Those are the exponential growth problems. Tomorrow we'll work on the decay problems. So important, we're nearing the end of the third quarter. Make sure you're turning in your work and you have completed all your assignments. So we will complete our exit ticket in a little while after we finish our lesson. Our do now says, this is the scenario. Let's imagine that today is the deadline for turning in your class trip money and you've forgotten again. Oh boy. I know some of you, including me, can identify with this. Let's complete the chart with helpful and unhelpful thoughts. So an unhelpful thought might be, I'm too dumb, I'm too forgetful, I'll never get this right. I don't know why I can't remember anything. What's wrong with me? A helpful thought might be, maybe I need to get an agenda and start writing things down. Getting ready for high school, that would be a good thing to do. Maybe I need to use the calendar function or the list function or the note taking function or even the recording function on my phone. Maybe what I need is a quiet moment when I first get home from school to sit down and just mentally go through each period in my head and try to think, was there something I'm supposed to remember about first period, second period, music class? Oh, yeah, we're going on a trip. And let's get ready for tomorrow right now. Let's put that by the door, have a basket or a box I put everything in. One place I put it and I have it already. Let me talk to my mom or dad or whoever takes care of me right now, and let's see what I need to do. So those are helpful thoughts, okay? And helpful thoughts often lead to a plan, and helpful thoughts often help solve problems. So that's the place that we want to get to, okay? Not the unhelpful thoughts, beat yourself up. Helpful thoughts, okay? Let's move on to our lesson. So we've been talking about these exponential functions, growth and decay. Today we're just going to talk about exponential growth. We have a formula, okay? So growth occurs when a quantity exponentially increases over time. And we saw this all through the year with those COVID-19 cases. It's funny, last year when the students went out on COVID, we had just completed our um, exponential growth lessons, and here we are. So this is definitely virus and bacteria math we're talking about, healthcare math, everyday life math. So we have a formula for exponential growth, and the formula is y equals a times the quantity of 1 plus r. So 1 plus r, and that is raised to the exponent of t. Now, what do these mean? So A is our initial amount. R is the growth rate. And T is time. How long are we doing this for? So this is our initial amount, our growth rate, and this is time. Now, how's that going to work? Well, let's take a look at the first problem. The original value of an investment, so it's not just healthcare, it's money, right? And the original value of an investment is $1,400, and the value increases by 9% each year. Use an exponential growth function to find the value of the investment after 25 years. Now, you're going to need a calculator for this, but I do want you to identify your A, your R, and your T, because if you identify these first, you won't make some mistakes. So we've got the original value. That's the initial amount. That's $1,400. We've got a growth rate of 9%. We'll express that as a decimal, 0.09. And the time is 25 years. And time is in years when we talk about these problems. Okay, so let's set up our problem. So it's really plug and chug work. Y equals 1,400 times the quantity of 1 plus 0.09 raised to the 25th power. So you're definitely going to need a calculator. And when you plug in those values, you will get $12,072.31. So it pays to save, because the question is, what's the value of the investment? You invested $1,400 and ended up with over $12,000. Time is money, folks. We really mean it. That's a mathematically correct statement. Time is money. So use the power of compound interest. This isn't even compound interest. What do we get there? Okay, the cost of tuition at a college is $12,000 and is increasing, at a rate of 6% each year. Use an exponential function to find the tuition cost after 4 years. Our three pieces of information: our initial amount, our growth rate, and our time. So our initial amount is $12,000. Our rate is 6%. We'll express that as a decimal. And our time is 4 years. So our equation, or using our formula, y equals 12,000 times 1 plus 0.09, 0.06 raised to the 4th power. And using a calculator, we see that is $15,149.72. So the first year of college is going to be $12,000. The second year and the third year, we can figure that out by changing this exponent to a 2 or a 3. And the fourth year of college will be $15,149.72. So you add all of that up, you've got almost $60,000, probably by the time you buy books. That will be almost $60,000. So do well in algebra and get yourself a scholarship. Let's look at number 4. And maybe you want to try 4, 5, and 6 yourself, but number 3, excuse me, 3, 4, 5, and 6 yourself. But it says number 3, the number of student athletes of a local high school is 300, so that's our initial amount, and is increasing at the rate of 8% per year. Use an exponential function to find the number of student athletes after 5 years. So we're assuming that student athletes, the number of athletes, continues to increase year over year. So our initial amount here is 300, and our rate of change is 0.08, 8%, expressed as a decimal, and our time is 5 for 5 years. So our formula, y equals 300 times the quantity of 1 plus 0.08 raised to the 5th power. And when we multiply that out, we have y equals 440 student athletes. And remember, we cannot have a partial answer, a percentage or point or a decimal or a fraction. We're talking about people. we are talking about whole numbers. So we have to have 440 student athletes. So let's move on to number 4. Number 4 tells us that annual sales for a company are $149,999 and are increasing at a rate of 6% per year. Use an exponential function to find the annual sales after 7 years. So our initial amount is 149,999. Our rate is 6%, and our time is 7 years. So our formula is y equals 149,999 times 1 plus 0.06, and that will be raised to the 7th power. And when we evaluate that, we will have $225,543.04. So sales are definitely looking up for this company. We don't know what they make, but things are looking good. So let's look at 5 and 6. So for number 5, the population of a small town is 1,600, and that is a small town. I had way more kids than that in my high school. And it's increasing at a rate of 3% per year. Some strong growth. Use an exponential function to find the population of the town after 10 years. So our initial amount is 1,600, and our rate is 3% expressed as a decimal 0.03, and the amount of time we're talking is 10 years. So our formula, y equals 1,600 times the quantity of 1 plus 0.06, that's our 6%, and that's raised to, 3%. I just made a little mistake there, 3%, and that is raised to a exponent of 10. And when we evaluate that, in 3 years, we will have 2,150 wonderful people living in that wonderful town. Doing wonderful things and growing their town. Hopefully they've got a great school system and a strong algebra program where they learn about exponential growth formula. Okay, number 6, and this is going to be our last problem for today. You do have some homework problems. 1985, there were 285 cell phone subscribers in Mayville. I wonder if that's the town from the prior problem. The number of subscribers increased by 75% per year. That is explosive growth after 1985. This is something you'll see in standardized testing. I want you to pay close attention for the next couple of minutes. We are asked to find the number of subscribers in 2008. So first of all, our initial amount is that 285 subscribers right here. Our rate is easy enough. That's 75%, 0.75. But our time, we're looking at from 1985 to 2008, okay? That is 23 years. And when you see problems in standardized tests, they will often do something like this. Because if they don't put from when to when, then the test wouldn't stay current. So if they said how many, what's the growth from 2010 till the present day, well, some kids could take the test in 2011 and some kids could take the test in 2018 or 2021. So you'll see them written like this. So you have a beginning date and an end date, and they want you to remember to figure out how many years that is. So our time is 23. Our exponent will be 23. So our formula, when we insert our data, will be 285 times the quantity of 1 plus 0.75 raised to the 23rd power, and that will end up being lots of subscribers. In 23 years, they've gone from 285 subscribers to 110,845,988 subscribers. That is explosive growth, and that's why we need an exponential equation in order to illustrate that. So for homework, you're not doing all of the problems. Let's go back and look at our assignment. We're doing 1, 4, 6, and 8. So let's go to our homework paper, and I want you to do number 1, number 4, number 6, and number 8 tonight. These are the exponential growth problems. And let's go back to our exit ticket. We are going to write the exponential growth formula. I'm hoping that you've figured it out by heart and describe what these variables mean. So the formula is y equals a times the quantity of 1 plus r raised to the t value in an exponent, where a equals our initial amount, r equals the growth rate, and t equals time. So good job today. Good job understanding exponents. Keep practicing, keep working hard, because as you do, you'll be great.